Okay, for 13, 14, and 15 for that matter, we're going to take a look at how to use the graphing calculator to solve an equation. And the cool part about this is once we have this technique down, whenever we have an equation, we'll always be able to solve it with the graphing calculator. So let's get right down to business. So for 13, what we need to do is there's a left side and a right side of the equation, right? The equal sign divides it in half. We're going to graph one side as one equation, so y equals y. We'll use y1 because that's what our calculator does. Y1 equals 4w squared, 4x squared, and we're going to graph the second one as y2. So this part over here is y2. We'll put those in, and wherever they intersect is going to be the solution, because where that means that's where they're equal means they will cross each other's path, and at that point they are equal. And there may be more than one, and in this case I think we have a really good chance of that happening. So we're going to for the Casio turn it on, come to our menu, we go to the graph. Oops, graph. Go here. It's let's clear this one out, so we'll delete it. That was from our last one, F1, and we'll put in 4x squared. Okay, so we won't use w or n because our variable for the graphing calculator is x. So we hit execute. So that's y1. Y2 will be this side here. So notice the negative. That's not a minus. This one's a a negative. Or a minus, however, I guess minus we think of as subtraction, so it's not, it's this one, 9x, and then the second one, the subtraction between the two needs to be this symbol here. Okay, so we've got the two graphed there. We'll hit enter to execute that. We'll go to the draw and we'll just see what our window looks like. Okay, so we're a little bit out. We might want to zoom in a little bit. And how we do that is we hit shift, we do V window, or we do stretch. There's a couple different ways in here. Let's see, V window, we can manually do this. So looks like we don't need to go all the way out to -9, so let's go at -5 to 5, and you have to hit execute each time. The Y values, we saw it goes down to -6 is okay, but we want probably to go to, let's say, 15. I'm not really sure, but let's do that. And then now when we go to execute and then draw it again, we can see more of it. Okay, and some of this is, when you use this feature, you're just making it bigger to see what you want. And see, maybe we want to see a little bit more. But what I'll just show you is we've got tools here to do it. And so there's a G-solve. I think that's the right one, right? G-solve. And then we've got these choices. What we want is intersection. And what's really cool with the Casio, once we hit intersection, it finds all the intersections. And now it's telling us one is at -2, 16. That's why we can't quite see it. It's right off the graph. But watch, if we hit the right arrow, it'll go to the next intersection because we can see that one. So it's finding us this one, -2, 16. So x equals -2 is a place where we get an intersection. So for this one, we could say w equals -2 is one of the solutions. And then we can go to the next one, and notice it tells us when x equals -0.25, both y values are the same as well. So what we're focusing on is we've solved for x. So the other one is -0.25. Now in Alex, if they want a fraction, you'll just have to recognize 0.25 is actually, -0.25 is actually -1/4. Okay, so that's our answer. And we did it with the graphing calculator. You can also move the square over. You get it all equal to 0. You factor it. That's another way to do it. But I'm just going to show you this way. I'm sure Alex has shown you the other. So now let's go with this one, 14. We'll do these all together. Again, left side, we'll just make that y1, or we'll make it y2. Who cares? We'll make this one y1 or y3. It doesn't matter. But what we're going to look for is the intersection of these two graphs. Okay, so let's bring back our graphing tool, and let's see, how do we get back? This is always shift. There we are. We're back to the place where we do the graphing. We'll delete that one, and you'll see I'm not still, and again, it doesn't matter which one you put in first. I'm kind of doing this to show you that, but you have to put the right, make sure you get all your negatives and everything, because as they say in programming, garbage in, garbage out. So if we put the wrong thing in, of course we're going to get the wrong answer, mostly. 2n squared plus 14. Now, right now I'm up in the exponent, so be careful. See, if I just hit plus, I'm still up in the exponent. That's not where I want to be. So let's see if I want to delete that. Let me put the 2 back there. So I have to right arrow to get back down to the input part of the line, plus 14x plus 24. So that's my first function, and then y2, I'll put the other side, and I'll just do it as it is. X plus 4, and then I'll square it. Okay, and again, we'll have a red and a blue, and where they intersect, that's what we're looking for. So we draw it, and again, we might need to, if we have to resize our window, you could shift vertical window. Actually, I want to go back a little. I just want to see a little bit more. So let's make that negative 10, and let's make that 2. I don't know, And then I think we're seeing pretty good, right? So let's just execute, draw, and we've just centered it. Okay. Now there's 2 intersections, and because these go up, now if you want, you could go, make your y value higher so you really see what's happening. But this blue is going to go up fast this way, so they're not going to intersect again. The geometry of these, they're not going to intersect again. So I just need to find, using graphical solve, and then the intersect. Now there's a y-intercept. That's where they cross the y-axis. That's not what we want. There's also ways of finding minimums, maximums, and roots are where it crosses the x-axis. But the one we're going to use is intersect. And the really cool part is it just finds it. Now the TI-84, you have to hit a few more keys and move it around. This one, it just tells us when x is equal to -4, we have equality. So, and again, when we come back here, remember to use in if that's what they're asking for, not x. And then to find the second one, we just hit the right arrow, and it goes to the other intersection, all visual, and we find that happened at -2. There's more than one solution, separate them with commas. Boom, done. Okay, you could also do all this algebra, boil this out, bring them over to the other side, get it equal to 0, factor it, and then solve for each of these. You'd see those, but this is the graphical way to solve. And while we're here, let's go ahead and talk about 15, because we're going to use the same features here, but this isn't a word problem. What I'm going to focus on is first I've got an equation. Okay, so if I graph this thing, I'll get the graph. Find all values for t for which the ball's height is 24. So the height is the output. So what it's really asking for, you could read all this stuff, but it's set it up for you. Yeah, it started at 4 feet. It's going up by 37 feet per second. That's its velocity. This is the effect of gravity. You'll see this a lot. It's -16x squared. That's the effect of gravity pulling it down. Well, what we want is we want to find when is it 24 feet high. And as you can see from this picture, it goes up and it's going to come back down because of gravity. So it's likely that there could be 2 places where that happens. So this is really all they're asking us to solve. And again, we'll use our method y1 and y2. Okay, and we may need to think through this a little bit, but that's okay. Let's see, yeah, just hit that and I come back. So let's put in our equations or our formulas. So y1, I'll just make it 24. And that's what we're going to see, is we're going to see a horizontal line at y equals 24. That's what that is. And then we graph this function, 4 plus 37x subtract 16x squared. Now, since I know the intersection is going to take place when y is 24, before I go to do all this stuff, let's see, let me go Shift V window. Notice that's what shows up. I'm going to make my y max, it's 15, but I know I need to be at least 24. Let's make it 30. And my x max, again, since this is a ball being thrown up, I'm going to assume time 0 is x, so I probably don't need to be negative time, right? Because it's a ball being thrown up. It's starting at 4 feet. Let's go with 10. I don't know. Again, some of these, this is not crucial. You just kind of eyeball it. You draw it, and then, okay, that was good. I could have only gone to 4, and I would have been fine. But I see the two intersections. It goes up, hits 24 feet, goes a little bit higher, it comes back down. So that's great. I just need to find when those happen. So I go to graphical solve and I do intersect. And cool part is I get the first one. First one happens when t equals, I wish I could get this calculator just to stay on top. My other ones do 0.861, let's see, nearest hundredth, 86, 0.86. Okay, that's the nearest hundredth. We're supposed to use the or button here instead of the comma. So it's there, or arrow over, and it finds the other one, 1.45. And again, these are seconds, right? Doesn't ask for units. If it did, though, these are seconds. After t seconds. Okay, so one of those two does it. Again, graphing calculator solving for an intersection. Such great power, and it's going to help us as you go into the next sections with exponentials and such. You'll be able to solve any equation known to humankind with this process. If we have an equation, you graph the left side, you graph the right side. Wherever they intersect is your solutions, and they can intersect more than once with some of these graphs. You get into trigonometry, they can intersect an infinite number of times. But this is really, it's great stuff. So keep up the good progress, and we'll move on to some more problems.